Welcome back to Infinite Union, your portal to the technologies shaping our future. Today, we're delving into a material so revolutionary, it sounds like it was lifted directly from the pages of a science fiction novel. What if I told you there was a substance 200 times stronger than steel, yet so astonishingly light that a single sheet large enough to cover a football field would weigh less than a single gram? This isn't science fiction, it's science fact. It's called graphene, and it's poised to change everything you thought you knew about the limits of technology. From batteries that could power your devices for weeks on end to elevators that could climb into space, this single layer of carbon atoms is the cornerstone of a new technological era. But if this wonder material is so incredible, why isn't it everywhere? Stick with us as we uncover the secrets of graphene, the material that could redefine our world. Imagine taking a simple, everyday pencil. The lead inside is actually graphite, which is made up of countless layers of carbon atoms stacked on top of each other. Graphene is what you get when you isolate a single one of those layers. This one-atom-thick sheet is a flat honeycomb lattice of carbon atoms, and this unique structure is the source of its almost magical properties. It's the thinnest material ever created, yet it's also one of the strongest. It's nearly transparent, incredibly flexible, and a better conductor of electricity and heat than any material we've known before. The story of its isolation is just as remarkable. In 2004, two scientists at the University of Manchester, Andrei Geim and Konstantin Novoselov, used a simple piece of Scotch tape to peel away layers from a block of graphite. They repeatedly peeled the layers until they were left with a film just one atom thick, pure graphene. This deceptively simple experiment earned them the Nobel Prize in Physics in 2010 and opened the floodgates to a world of possibilities. Let's talk about power. We're all familiar with the daily ritual of charging our phones, laptops, and watches. Batteries are the lifeblood of our modern world, but they are also one of our biggest limitations, draining faster than we'd like and taking hours to recharge. Graphene is set to completely shatter these limitations. Because of its incredible conductivity and massive surface area, graphene can be used to create supercapacitors that charge in mere seconds and hold vastly more energy than the best lithium-ion batteries available today. Imagine your electric car fully charging in the time it takes to get a cup of coffee, or a phone battery that lasts for an entire week on a single, 10-second charge. This isn't just a distant dream, researchers are already developing graphene-based batteries that demonstrate these incredible capabilities. This eco-tech innovation could also make our power grids more efficient, storing energy from renewable sources like solar and wind with unprecedented effectiveness, paving the way for a truly sustainable energy future. The age of infinite batteries is closer than you think. The strength-to-weight ratio of graphene is where things get truly exciting and futuristic. Being 200 times stronger than structural steel while being lighter than paper makes it the ultimate building material for the 21st century and beyond. Think about transportation. Graphene composites could be used to build lighter, stronger, and more fuel-efficient cars and airplanes. This would drastically reduce our energy consumption and make travel more sustainable. The material's durability would also mean longer lifespans for vehicles and infrastructure, from bridges to buildings. But why stop at Earth? One of the most mind-bending concepts that graphene makes plausible is the space elevator. For decades, it's been a staple of science fiction, a cable stretching from the Earth's surface all the way into geosynchronous orbit. The main obstacle has always been finding a material strong enough to support its own weight over such a colossal distance. Graphene is that material. A ribbon made of graphene could theoretically be strong enough to create this celestial highway, allowing us to lift cargo and even people into orbit without the need for expensive and polluting rockets. This would revolutionize space exploration, satellite deployment, and could even be the first step towards colonizing other worlds. So, if graphene is this miracle material, the key to unlocking a sci-fi future, why aren't we all living in graphene houses and driving graphene cars? Why hasn't it replaced silicon in our computer chips and lithium in our batteries? The answer, as it often is in science, lies in the immense challenge of mass production. While scientists can create small, pristine flakes of graphene in a lab using the Scotch tape method or more advanced techniques, producing it in large, high-quality, and affordable sheets is a completely different ballgame. The process is incredibly complex. Current methods like chemical vapor deposition can grow large sheets of graphene, but they are expensive, slow, and often result in imperfections in the atomic lattice. These tiny defects can compromise the material's incredible properties. Think of it like trying to weave a flawless, football field-sized blanket with threads that are only 1 atom wide. A single mistake can unravel the whole thing. Scientists and engineers around the world are in a race to crack this code. They are exploring new methods, from flash heating carbon sources to using liquid metals, to find a scalable and cost-effective way to produce high-grade graphene. The moment we solve the puzzle of mass production is the moment the graphene revolution truly begins. The future powered by graphene is brighter, faster, and stronger. Beyond space elevators and infinite batteries, its applications are nearly limitless. In medicine, graphene biosensors could detect diseases at the molecular level, and its strength could be used to create next-generation biocompatible implants. In electronics, its superior conductivity could lead to ultra-fast computers and flexible, transparent screens that you can roll up and put in your pocket. Graphene-based water filtration systems could provide clean drinking water to millions, using a single sheet to desalinate and purify water with incredible efficiency. This is a true ecotech innovation that could solve some of humanity's most pressing problems. We are standing at the threshold of a new material age. Just as bronze, iron, and silicon defined previous eras of human history, graphene may very well define our future. The journey from laboratory discovery to global ubiquity is a long one, but the potential rewards are immeasurable. The future of technology is being written today, one carbon atom at a time. The question is no longer if graphene will change our lives, but when. So, I have to ask, if it were built tomorrow, would you ride a space elevator made of this incredible material? Let me know your thoughts in the comments below. Thanks for joining us on this journey into the future. If you found this exploration of graphene fascinating, be sure to like this video, subscribe to Infinitugnal, and hit the notification bell so you don't miss our next deep dive into the technologies that are shaping our world. Until next time, stay curious.